Okay, so today's lesson 13A, I'm going to split into a series of skills. I don't want to overwhelm you, and so for that reason we're going to break it right down. We'll just sort of do the first question, go do some textbook work, come back, go through the second few, then go back to the textbook and see how we're going for time. So 13A, logarithms in base 10. Just show of hands, anyone seen logarithms before? Couple of you? Excellent. Okay, so for the rest of you, it's going to be pretty fresh. So, we'll go through it nice and slowly. First, we're just going to solve them, okay? And then you'll notice in the second part, we've got about how we're going to understand what is a logarithm, what does it mean. So for the first part, we're just going to perform operations. So this is the rule, okay? Log 10 to the power of x equals x. So that means we need to try and express this power here, or this space here, as a power of 10. All right? So 1,000, that is 10 to the power of 3. All right, so that's our first step. We express it as a power of 10. And once we've expressed it as a power of 10, it simplifies to that power. So we have log 1,000, that's log to the 10 to the power of 3, which is 3. Okay? Over here we have log of 1 on 10. So we need to express that as a single power of 10, right? So we're looking at that and going, at the bottom that's 10 to the power of 1. I can take it to the top, make it 10 to the power of minus 1. All right, once we've expressed it as a single power of 10, it's going to simplify to the power, which is minus 1. Okay, for C, there's a couple of things that are going on. We have log of the cubed root of 100. So I might do it over 2 steps kind of thing. So what we have is firstly the cubed root, which means to the power of a third. All right, cubed root is to the power of a third. Square root is to the power of a half. The fourth root would be to the power of a quarter. So that's the cubed root. And we have the 100. 100 is 10 to the power of 2. So we have 10 squared to the power of a third. And when we have it like this, we're multiplying the powers together, right? 2 times a third is 2/3. Okay. It's now expressed as a single power of 10. So it simplifies to Alright, so you can see how those index laws are important, right? They're presenting themselves here. Any questions so far? Alright, on to D. We've got 1,000 on the square root of 10. So the first thing we're going to do is express both of them as a power of 10. So at the top I've got 10 to the power of 3, and at the bottom I've got 10 to the power of a half. Okay. Now we're using the index law where it's the top power, take away the bottom power. So it's going to simplify to 10 to the power of 3 take a half. All right, let's reiterate those fraction operations. 3 take a half. If I need to perform that, I need to express 3 with a denominator of 2, right? So 6 divided by 2. 3, one way we can write it, is 6 divided by 2. They now have the same denominator. Top take the top, 6 take 1 is 5, and the denominator remains the same. 5 divided by 2, that's 2.5. 3 take a half, 2.5, that's what we expect, okay? So be competent with those. Express it as a single power of 10, and then it simplifies to power. Okay, on to E, can be quite similar. The top is already a power of 10. And the bottom, we're just going to put to the power of 2. All right, I'm putting brackets there. 100 is 10 to the power of 2. And then the 2 and the B will distribute, right? So I'll do this over a series of steps. Log. Okay, so in the first step, just expressing the 100 as 10 to the power of 2. In the second step, distributing the 2. In the third step, the top power, take the bottom power, and then we've expressed it as a single power of 10, so it simplifies to A, take 10B. All right, let's talk, so we'll stop there, and we'll go ahead and have a go at some of the questions. All right, so even if you're not finished question 1 and 2 there, that's okay. We're going to pause. Looks like we've sort of grasped the skill. We're just going to take it a little bit further, and so we're on page 16, and we're looking specifically at question 3. What I'm doing here is I'm explaining, I think, what's the most important skill, and then we're going to have time where we can come back and explain the meaning of it, the significance of it, and some of the more intricate problems involved in it. But this is the most important takeaway. So we looked at just logarithms in base 10. Now we're going to look at logarithms in base A. That's where we can have that base as any number. And so the rule is quite similar, right? If we have the logarithm in base A of A to x, it simplifies to x. So that means we now need to consider this subscript, 2. Okay, here it's 2. So that means that the base of this logarithm is not 10. The base of this logarithm is 2. So now we need to express 8 as a power of 2. Not a power of 10, a power of 2. So 8 we know is 2 to the power of 3. 2 times 2 times 2. Okay, so once we've expressed it as a single power of that base, it just evaluates to the power. Okay, 1 on 16, the base is 2. So I'm looking at the bottom there, 16, that's 2 to the power of 4. And we'll take it to the top and make the power negative. And then it will simplify to the power. Okay, logging base 3 of 1 on 9. 9 is 3 squared. All right, now on to D. Here we have log of 100. There's nothing written there. There's no subscript. So if there's no subscript, we assume base 10. All right? Sometimes they'll even chuck a 10 there as well. That means it's base 10. But if there's nothing written there, you assume the base is 10. So 100, that's 10 squared, which simplifies to 2. All right, so the base 10 will pop up in this exercise as well. All right, we have log of A, log in base A of A root A. So no numbers involved at all. All that means is we need to express this as a single power of A. So log in base A, it's A to the 1 times A to the half. We'll collect them together. 1 plus a half is 1.5. So you could write that as 1.5. You could write it as 1.5 as a mixed number. We tend to prefer mixed improper fractions, but it doesn't matter at all, really. Okay, and so that will simplify to 3 on top of 2. All right, we express it as a single power of A, and it will simplify to the power. Same with the last one. Log of the square root of t, we have 1 on root t. So we'll express that as 1 on t to the half. We're going to take it to the top and make the power negative. We've expressed it as a single power of t, so it's going to simplify to the power. All right, so we'll jump forward from where we are. We're going to jump forward to exercise 13B, question 3, and we'll dedicate 5 minutes now to that exercise. All right, so the reason the reason we're jumping around a bit, right, is because there's a bit to get through, but so far we've just focused on the most important skill, okay? That is simplifying of logarithms. Now we're going to look at understanding what they mean and answering some questions in the context of what logarithms are. So here I have the graph of y equals 10 to the power of x. Okay? So you can see on the x-axis I've got 10 to the power of 0, which is 1. 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 would be 1,000, so it's exponential graph, right? It's just going up forever. Now, we know, if I was to say, what's log of 100? We could write that as, that's log of 10 squared, and that would simplify to 2. All right, so log of 100 is 2. Now, we can actually pull out our calculators, because we've got logs on our calculators. And so let's do that now. I'll show you where it is. All right, can you see the log button? Anyone see the log button? All right, it's next to, it's 2 buttons above the 8, all right, or below the x squared button. You see log. So if we type in log 50, all right, let's type that in. I've got 1.698. All right, I've rounded it wrongly there. 1.69897. So it's going to round to 1.7, right? What this means for us, okay? Let's compare what we've done here with what we've done here. If we've got log 100 equals 2, well, we know 10 to the power of 2 is 100. We've got log 50 equals 1.6989. It means 10 to the power of that equals 50. Okay, so here's what it means. Log of 100 is 2. Log of 50 is 1.7. 10 to the power of 2 is 100. 10 to the power of 1.7 is 50. Okay, so then if we have log 200, we evaluate that, type that in. Log 200, log 200, we've got 2.301. All right, 2.301. And so what this means then is 10 to the power of 2.301 equals 200. So we've got a logarithmic statement. Okay, here's a logarithm. And then we've got an exponential statement. Hopefully we can see a link between those. Okay, log of 300. All right, that's just going to tell us 10 to the power of what number equals 300. All right, very good. So let's move on to the questions that we're asked to perform here then. So you've got the graph there and an explanation of it. Question 3. Using your calculator, evaluate and hence state the significance of your results. So the first one we're up, log 22. Type it in. I've got 1.3424. Now, we will do 3 significant figures unless otherwise stated. Okay? So I'm going to state to 4 figures and I round the 4th one. Okay, now state the significance. What does this mean? We found log of 22 is 1.34. This means 10 to the power of 1.34 equals 22. Okay, so log of 22 is 1.34. Therefore, 10 to the power of 1.34 is 22. All right, in the next one, we've got log of 694. 2.841. Okay, write 4 figures, round the 4th. That's going to be 2.84. Now I'm going to keep it as a logarithmic statement and then convert it to an exponential statement. So log of 694 is 2.84. What does it mean? It means 10 to the power of 2.84 is 694. Okay. On to C, log of 3,421. We've got 3.534. We'll round. Okay, so we've got the logarithmic statement. Log of 3,421 is 3.53. Therefore, 10 to the power of 3.53. 3,421. All right, I'll spin the board around if we're all happy. Okay, 15. Write the following in the form 10 to the power of x, where x is correct to 14 decimal places. 4 decimal places. All right, so we're going to do, okay, well, what's log of 15? We're going to put that in our calculator. And we've got 1.176. Now, it says 4 decimal places. So what that means is 4 numbers after the decimal place. So that means we need to write 5 numbers after the decimal place and round the 5th one. So 5 numbers after the decimal place, round the 5th one. Okay, that's what log of 15 evaluates to. And it wants us to express 15 as a power of 10. Well, 10 to the power of 1.1761 is 15. All right, so this is pretty well the same question, just asked differently. They're asking it in a different way. All right, 2,431. So we're going to go, okay, well, what is log of 2,431? We've got 3.38578. Okay, I'm writing 5 numbers after the decimal place. I'm rounding the 5th one. And then I'm making a statement. Okay, how do I express 2,431 as a power of 10? It's 10 to the power of 3.3858. Okay, very good. So they're just trying to draw out some relationships between the exponential statements and the logarithmic statements. Then we have logarithmic equations. Okay, so here we're trying to solve for x. We're trying to get x by itself. Now the process here is not complex. The base of this logarithm is 10. The way you get rid of a logarithm is you raise it to the power of its base. So we're just going to put both sides to the power of 10. Now, remember with algebra, we can do anything we want as long as we do it to both sides of the equation. 10 to the power of log x, this part here, simplifies to x. And so our answer is x is 10 to the power of 0.351. We could choose to evaluate that in our calculator and around it. It hasn't specified which way they want us to present the answer, so we're just going to leave it as a power of 10. Okay, with b, we have log x equals 2.3. We're going to raise 10 to the power of both sides. Okay, why 10? Because the base of the logarithm is 10. We want to get rid of the logarithm. We're trying to isolate x by itself. To the power of log x. All right, so looking along here, I mean, this is a cheese of a question, right? You're looking at that and seeing the relationship between there and there, okay? All you're doing is taking that, putting it to the power of 10, x goes by itself. That to the power of 10, x goes by itself. Okay, but again, we're just really trying to slowly draw out that relationship. Okay, so we're just going to keep going with where we're up to. So we've polished off the questions in 13A, and now we're going to move on to the ones in 13B. Okay, so we're at write an equivalent exponential statement. So this here is a logarithmic statement. Okay, it's a logarithmic statement because there's a statement about the logarithm being equal to some number. So this is the relationship, right? We take this number, 4, we raise it to the power of the base. 4 to the power of 2 is equal to 16. Alright, that seems, it's an obvious statement, right? 4 squared is 16. Here's the logarithmic statement. This is the exponential statement. Okay, logarithmic statement, exponential statement. Okay, log in base 3 of 9 is 2. Well, we take, I did that around the wrong way, sorry. That should be 2 to the power of 4. Both are true, but 2 to the power of 4. So we take the base, we raise it to that power, 2 to the power of 4. So over here, we take the base, 3, we raise it to that, and it's equal to 9. Alright, and then the last one, 5 to the power of minus 2 equals 1 on 25. So in that question, we're converting from a logarithmic statement to an exponential statement. In the next question, which I'm going to do right underneath it, we convert from an exponential to a logarithmic. So I'm just going to do it right underneath here. 2 to the 5 is 32. We have 3 to the 4, and 2 to the minus 3. Okay, so whatever the base is, that's the base of your logarithm. So for the first one, we have a logarithm in base 2. Alright? Then, whatever it evaluates to over here, that's what you're performing the logarithm of. We have log in base 2 of 32, and it evaluates to 5. Alright, so we're just basically rearranging this statement, making it an alternative way, right? So that base is the base of the logarithm. That number is what you're performing the logarithm of, and the power is what it evaluates to in your logarithmic statement. So in the next one, our base is 3. We're performing the logarithm in base 3 of 243. And it evaluates to 4. Yep.
I think 3 power of 4 is 81.
You're correct. Yes.
3 power of 5.
We have a typo here. Let's change that to 81. Because you got 3, 3 to the power of 327. Yeah, you're correct. Yep. So let's change that to 81 rather than 243. Yeah, 3 to the 5 is 243. Alright, so same principle holds. Let's change the question to say 81 rather than 243. Base is 3, okay? The base here, that's the base of our logarithm. We have 81, so we have the log in base 3 of 81, and it simplifies to 4. Okay. So the last one, 2 to the minus 3. The base is 2, so we have logarithm in base 2 of 1 on 8, and it simplifies to minus a third. So we've gone through a lot of questions here, right, but they're just sort of one-step questions, aren't they? So if everyone's feeling okay, I'll be pretty keen to finish it off because, again, they're just one-step questions. Run okay? All right. So I'll clear this. So the last one there, question 4. We'll get that 4a. Log in base 2 of x equals 4. B, log in base 3 of x equals 1.5. C, log in base 6 of x equals 2. And then that's just a recollection of what we've been doing here. I'll do them, but okay, so in question 4 here, where again, we're solving logarithmic equations, right? Solve for x. Now we saw with base 10 logarithms, we had to raise both sides to the power of 10. Here, we have base 2. What should we raise both sides to the power of? 2, all right? So all we're doing is making a statement 2 to the power of, logging base 2 of x, equals 2 to the power of 4. So we're keeping the power of 2 on both sides. Now that we've expressed this, okay, 2, they have the same number, the same value, so it's going to simplify to x. 2 to the 4, or you can write it as 16. Either is completely fine. Okay, on to the next one. We're solving a logarithmic equation with a base of 3. We raise both sides to the power of 3. Okay, simplifies to x. And then in the last one, logging base 6 of x is 2. The base is 6, so we raise 6 to the power of both sides. 6 squared is 36. So we're not fussed how this answer is expressed, right? What we're interested in is, have you performed that process? All right, have you simplified it? Solve the equation. Okay, D is not a logarithmic equation. This one just wants us to simplify. So just recapping one of the skills we did at the start of the lesson. Logging base 3. You know what? Let's save them for next lesson so that we can pop back and recap logarithms. So we've done a lot there. We've gone over a lot of skills. But the first part we did, that's the important part. That's the important skills. This other stuff is just trying to draw out the relationships. So for the remainder of this lesson and for homework, we'll have a wrestle with those questions from 13A and 13B that are in the checklist. All right, so you've got enough knowledge now to start working through them.